Alright, this is the lesson for day 129. Everyone say hi to the video.
Hey!
Okay, cool. So, this is a Throwback Thursday lesson, so you do need to know some of this geometry, TBT, right? We're going to be doing reviewing special right triangles and our trig ratios from geometry, because we're going to go into trigonometry, which is based on that. Okay? A lot of commentary today on the video. Any other sounds? Any other exaggeration? Okay, like this video if you like the sounds. Alright, anyways. So, okay, so first one, remember Pythagorean theorem? Okay, this is one of the easier things from 7th grade. This only applies to right triangles, and Pythagorean theorem. Pythagoras figured out, hey, if we have a right triangle, you could take one leg, the length of the leg, we can pretend that there's a square on it. If we take this square, the area of this square, and we add it to the area of this square, it'll equal to the area of the hypotenuse square. Okay, so a squared plus b squared is equal to c squared. Yes, Ashley? Cool, why don't you come on up and show us again, and leave your phone while you're at it.
Oh, you got caught up?
You're sad.
Ashley, you shouldn't use your phone in class in the first place when we're learning.
Okay, that's one phone for this video. Okay. Now walk around. Let's make it a goal. Okay, so next one. What do we know about this? 30, 60, 90 triangles. What do you remember from geometry? Talk to your neighbors.
Guys, one sec. I know the answer. Look at this. Look at this right here. I know that the hypotenuse is 2 times the short side, and to get the short leg, it's the long leg over the square root of 3. I always think the short 2 times square root of 3.
Yes. Okay, so
I have all the answers.
30, 60, 90 triangles. Okay, this is a special case triangle. So it originally came from an equilateral triangle. What do we know about equilateral triangles? They have what? Equal sides, and then what else? They have equal angles as well. So all angles are 60 degrees, okay? So on an equilateral triangle, we could actually take the equilateral triangle, cut it in half, and then when we cut the 60-degree angle in half, these become 30 degrees at the top. So you'll notice that it's been cut to look like these, okay? And these have when we apply the Pythagorean theorem to them, we get this we get some patterns going that are always consistent with 30, 60, 90 triangles. So the smaller leg is x. I heard some people pulling out their notes from their calculators.
Right here.
Yep, that's right. I did see them. That's good. So you got your x is your small leg, and then on a 30, 60, 90, we could assume that the long leg or the hypotenuse is twice the small leg, and that we could take the long leg and we can multiply the small leg times rad 3 and you get the answer. Okay? 30, 60, 90. That's in your notes. So why don't you take a moment, write down just what's circled right here in your notes. Okay? If you haven't already, go.
90.
Good. The next triangle is 45, 45, 90. Turn your neighbors. Describe what are the patterns here that you, or what are the assumptions when you use the 45, 45, 90.
You're going to want to times the leg by square root of 2. And if you want to find the leg, you're going to want to do the hypotenuse over the square root of 2. Yeah, but you know what I mean? Yeah.
If the hypotenuse is 4,
Okay, so what's the assumption we can make on these, everyone? On the 45, 45, 90? The legs are the same, and what else can you do with them?
Put those two sets.
Okay, so 40 eyes up here. A 45, 45, 90 triangle comes from a perfect square. We know a square has equal sides, so all their sides are the same, and then all your angles in a square are 90-degree angles, okay? So when we cut this in half, or we could fold this in half, we get the special case triangle with a 45, 45, 90, okay? So these are the rules down here. So why don't you take what's, actually I'll highlight it. Please write down the highlighted portion in your notes, okay? That's all you need to do right now, this highlighted portion. Go, take a moment and do that if you haven't yet. Continuing on here. So here we go, we're going to apply these. So, who's really good at these?
I am. You want me to do it right now?
Okay, David, come on up. No, you come on over. I did this in first period. I want to. This is our review, so I want students to teach. Who wants to teach? All right, come on up. Braden's coming up.
I'm gonna do.
Number 1 or 2.
Do I just do what do I use?
So all you got to do is tell the class what do you notice and how would you work it out. You could use marker.
Can I draw on there? Will not draw, work it out?
Yep, you could draw on here. But I want you to tell the class what do you notice about one of the problems and how would you figure out the rest of the sides.
First off, I can see here that this is a 45-degree angle, and that makes me assume that this one is going to be a 45, 45, 90 triangle. So I can assume that this right here is going to be the hypotenuse and these are going to be the legs. So now that I know that those are the legs, I know that this one is going to be 4 as well. Because the hypotenuse legs are always exactly the same. Now what I'm going to want to do here is I'm going to want to times the leg over here, 4 times the square root of 2. And then once we do that, we got to square it together. Then we're going to get 4 square root of 2. And that should be our final answer right there.
Do you all agree with Braden?
I agree with you.
Yeah, let's clap. Good job. All right, who wants to do number 2? Number 2. Number 2. One more volunteer. Michael, you volunteered earlier. Come on up.
For the first one.
Now you're done. Come on up here. You got it. That's easier. Yeah, take your notes up here from last year. Okay, number 2. So we got number 2. It looks kind of crazy. We're supposed to find the missing side lengths. Okay, so again, you're going to teach everyone by saying what do you notice and what you would do, okay?
Hey, Michael.
So, I guess this
What do you
one,
notice?
You notice that that's 4.
Okay, what else
and
do you
it's
notice?
the big leg.
That's the big leg, okay?
So you divide by 2.
What kind of triangle is it?
It's a 30, 60, 90.
How do you know?
So you get that 2 because you divided 2 by that
I
one.
want my questions answered.
And then you get this one by being 2 rad 3.
Why can you make those assumptions, Michael?
Because you have the long leg.
But how do you know? That doesn't mean anything. Just because it's a long leg, you always divide by 2?
Because the formula tells you so.
Which formula?
The 30, 60, 90.
Oh, is this a special triangle?
Yeah.
All right, good.
Because there's 30 and 90, so that one has to be 60.
Yes, because all interior angles add up to how much on a triangle?
180.
Good. Let's all give a hand to Michael. Okay. Cool. Nice. So what we're going to do now, you're going to go to number 3 and 4 with your group. Okay, 3 and 4. Ready, set, go. I'll give you 1 minute. Okay. What special case triangle is number 3, everyone?
45, 45, 90.
Good. Okay, so it's 45, 45, 90. So that means this side should be A and this side should be A, right?
Yes.
Good. And then that means the hypotenuse is how much?
2.
No. A times rad 2, right? Would you agree that this is the pattern we need to follow from our notes, right?
Yes.
So that means, shouldn't 2 be equal to A rad 2, right? Would you agree with that?
So that means that
So how would you figure out this? Well, you would take your,
A equals 2.
no, you take A rad 2 is equal to 2. How do you solve for A?
You subtract or you divide it.
You could
Divide both sides by rad 2.
You could square it or divide both sides by rad 2. Okay, so let's do that and then finish the problem, okay? Everyone's doing this. I'll pause there again. Everyone's finishing this problem.
Divide it by
What's the answer? What does this simplify to be? What's this simplify to be, everyone? Brad? Oh.
Oh, it's alright. It's alright. Don't worry.
What does this simplify to be?
Rad 2.
Rad 2. Is that true?
Yes.
Okay, good. Right, because you have to rationalize the denominator, and then you get 2, rad 2 over 2, which becomes 2. Okay? Number 4. Oop, give you a little bit of the answer. What are the answers of the sides for number 4?
The hypotenuse is 6.
Okay, hypotenuse is 6, and then what's his longer leg?
3 rad 3.
3 rad 3. Do y'all agree?
Amen.
That's right. Okay, cool. So that's the first Throwback Thursday lesson set. Okay, so now we're going to go do one more thing from geometry, which was SohCahToa. SohCahToa. Okay, I'm going to go back. Here you go. Some people needed this. Yes.
Are we going to put the SohCahToa like on a different page?
No, just keep it going. Or you can organize it however you like, but it's the same lesson. Okay?
SohCahToa. I love
Okay. Here you go, SohCahToa. So write these down, or remind your neighbors what you use SohCahToa for, actually. Throwback Thursday. Bring it back.
Miss Legan taught me. You know, I had a 69.8 and she wouldn't count it. I said,
Okay. So what is SohCahToa used for?
Triangle.
To find the sine, the cosine, and tangent of a triangle. Preferably a triangle with an opposite side, an adjacent side, and a hypotenuse.
Okay, good. So when you have an angle, you on every triangle. This is only this is only used on triangles, and we know there's gonna be the longest side's always the hypotenuse. Then we have adjacent sides and opposite sides of an angle. Okay, so we need to be able to find the sine, cosine, and tangent of any angle in a triangle. So we're gonna go into trigonometry, and there's the special case triangles are the ones that we need to worry about. Okay, so I'll do number 5, and then we're gonna do 6 and 7. Okay, so here are the directions. You don't have to write all this down. It's gonna take you like 3 minutes, I promise.
I don't remember it being this hard.
Yeah, I don't either.
Okay, so, well, let me bring you to where it should be. You'll get this. It's not that hard. Ready? Okay. So find the sine, cosine, and tangent of the labeled angle in each triangle. So on this first one, on number 5, I have a labeled angle of 30 degrees, okay? We could assume this is a 30, 60, 90 triangle. So I want to find the sine, cosine, and tangent of 30, okay? So I is up here. So I know I'm going to start with sine. I know sine is so it's going to be opposite over hypotenuse. So I look at the opposite of 30 degrees. What's the length?
1/2.
Excellent, 1/2. So I'm going to go 1/2, okay? And then what is the hypotenuse of the 30 degrees? 1. So it's like saying 1/2 divided by 1. What's anything divided by 1?
1. No,
No,
0.
itself.
Nothing.
Itself. Good. It's
I
itself. I know, but someone said 0 and nothing. It
Not
is.
someone.
Okay.
I didn't they say 1/2?
Okay, so this one's 1/2. So the sine of 30 degrees is 1/2. Okay? And we want to have a fractional answer. Now, you could have just gone to your calculator and put sine of 30. You get the same answer. But I want you to notice. That there's going to be a length or a bottom length and an up and down length, saying that there's going to be an x, change of x, and a change of y axis, okay? What happened last year?
We did it in decimals.
Okay, so I'm asking you now to go to, we're going to go to fractions. You have to go to fractions, okay? And it's just because it's going to support you and help you out with our trig, okay? We need to know it in fractions, okay? So I don't want you to use your calculator. You don't need to worry about it. Yes, sir?
How do you know it's sine?
Because it's asking. We're going to do sine. It's asking you the directions. Figure out the sine, cosine, and tangent of each angle. So this, we're not done with number 5 yet.
No, you gotta find all of them.
Yep. Okay, next one. Now I'm going to do the cosine of 30. So I'm going to go start with cosine and write cosine 30. And I know, from SohCahToa, it's AH. Excellent. So it's adjacent over hypotenuse, and we're going to do the same thing. I know the adjacent is not 1/2, but rad 3 over 2. So I'm going to write rad 3 over 2. All divided by 1. What's anything divided by 1? Again, everything. Everyone?
Itself. It has to be itself.
Okay, rad 3 over 2. Okay? So we know that the cosine of 30 degrees is rad 3 over 2. And if you did your calculator, you could put rad 3 over 2 and you get the same decimal. The reason why we don't want to use decimals is because they're not as accurate as a fraction. The fraction is the only true answer, okay?
Wouldn't a decimal be more accurate because it's longer?
No, because on a decimal, if it never ends, if it's an irrational number, you would never get the true answer because it's infinitely going, okay? And then we have tangent, okay? Tangent is, it's TOA, right? So we're thinking opposite over adjacent. So this is going to be the harder one on this example. Ready? Okay, what's the opposite of 30 degrees or tangent of 30? Opposite? 1/2. So eyes up here. So you got 1/2 divided by, what's the adjacent?
Rad
3 over 2.
Good, so now it looks like it's scary, right? This is just a complex number. Ready? Or complex fraction, actually. So eyes up here. This is just like saying 1/2 divided by rad 3 over 2. How do we divide fractions? We multiply by the what? Reciprocal. So isn't this the same thing as saying 1/2 times 2 over rad 3? Y'all see that? Again, how do we divide fractions? You multiply by the reciprocal. Okay, good. So now I could cancel some stuff out. The 2's could cancel out.
So it's 1 over rad 3?
Good. 1 over rad 3 is correct. But do we like a radical in our denominator?
No, so we have to times it by rad 3. And then it's going to be just rad 3, right?
That's it. Yep. Rad 3 over 3, actually.
Yeah, because you times the bottom and the top.
Okay. So this is a bit tedious, but we need to know how all these work because we're going to be building on the process here for our trig unit, okay? Okay, cool. So that's number 5. I'd like you to do the same thing for 6 and 7. You got 3 sine, cosine, and tangent of each of these. You'll notice similar numbers, okay? So I'll give you about 2 to 3 minutes to do this. Ready, set, go. Oh, David, bring me your phone. That's 2 phones. No, I'm not. Okay, so here are the answers. Ready? Check your work.
That's all the right answers.
And boom.
Oh, my gosh. Boom, boom, boom. Boom, boom. Oh, that would just be... Could it be the last one? Could it be rad 3 over 3?
No.
Yeah?
Okay,
Yeah.
so keep these handy. I know you're like, oh, I want to use decimals, but we need to use the fractions for a trig. These are going to be easier, okay? That's it.
I got a question.